Welcome to a fascinating journey exploring the world of quantum, edge, and cloud computing. Imagine a future where the information is processed at lightning speed, complex tasks are solved in a mere seconds, and your devices work seamlessly and securely without interruptions. And these innovative paradigms are making this vision a reality. So, from enhancing cybersecurity and drug discovery to streamlining cloud services and revolutionizing IoT devices, these technologies are paving the way for more efficient, secure, and connected future. So let's understand their complexities and explore how they are transforming our daily lives. So first, let's start with the quantum computing. Now, this quantum computing is a type of computing that harnesses the principles of quantum mechanics to perform operations on data. So unlike classical computers, which rely on bits which can be either 0 or 1, quantum computers use quantum bits or qubits, which can be both 0 and 1 at the same time. So this property is known as quantum superposition, and it allows supercomputers to perform certain types of calculations much faster than classical computers. Additionally, these quantum bits can also be entangled, meaning the state of one qubit is intrinsically linked to the state of another qubit. A simple real-life example of superposition would be a set of keys where one key unlocks multiple doors and the quantum computer searches all the doors simultaneously. This is in contrast to a traditional computer which would have to search one door at a time. An example of entanglement would be two people who are connected by a piece of string. So if one person moves, the other person will move in response even if they are far apart. So this quantum entanglement work in a similar way where qubits become linked and their states are intrinsically connected, allowing for faster and more efficient processing. And this real life example of quantum computing is quantum cryptography, which uses quantum principles to create secure communication protocol. One example is quantum key distribution, which uses entangled qubits to distribute a secret key between two parties in a way that is secured against eavesdropping. So to summarize this, we can say quantum computing is a type of computing that harnesses the principles of quantum mechanics to perform operations on data. It uses qubits, which can be in a superposition of states, to perform calculations much faster than classical computers. The quantum gates and algorithms are used to perform operations on qubits, and quantum cryptography is an example of real-life application of quantum computing. Next comes edge computing. Now this edge computing is a distributed computing paradigm that brings computation and data storage closer to the sources of data rather than relying on centralized data centers. So instead of sending data to a central location for processing, edge computing enables data to be processed and analyzed at the edge of the network closer to where the data is generated, and this reduces latency and improves responsiveness as well as allows for more efficient use of network resources. A simple real-life example of edge computing is the use of smart traffic management system. So this smart traffic management system uses edge computing to process real-time data from sensors and cameras installed on roads and intersections, and this data is processed and analyzed at the edge rather than being sent to a central data center to detect traffic congestion, accidents, and other issues in real time. And the system can then make intelligent decisions and take actions such as adjusting traffic light timings to optimize traffic flow and reduce congestion. And this improves the responsiveness and efficiency of this traffic management system, leading to reduced travel times and improved safety for drivers. So to conclude this, we can say edge computing is a distributed computing paradigm that brings computation and data storage closer to the source of data, which allows for faster processing and more efficient use of network resources. And a real life example of edge computing in action is smart traffic management system, which uses edge computing to process real time data from sensors and cameras to optimize traffic flow and reduce congestion. And then comes cloud computing. Now, this cloud computing is a model for delivering on-demand access to a shared pool of computing resources, including servers, storage, and applications over the internet. So instead of owning and maintaining your own hardware and software, cloud computing allows you to access these resources as needed on a pay-as-you-go basis. A simple real-life example of cloud computing is online storage devices such as Dropbox, Google Drive, or Microsoft OneDrive. And these services allows users to store and access their files from anywhere or any device as long as they have an internet connection. So with cloud computing, users can upload and store their files on remote servers which can be accessed from anywhere and can also collaborate on documents with others in real time. And this is much more convenient than storing files on local hard drives, as it eliminates the need to carry physical media and allows for easy access to files from any device with internet access. So to summarize this, we can say cloud computing is a model for delivering on-demand access to a shared pool of computing resources, including servers, storage, and applications over the internet. A simple real-life example of cloud computing is online storage services, which allows users to store and access their files from anywhere on device and collaborate with others in real time. Thank you.